Hydrograph is the response of the given catchment to a rainfall input. So it's like the output signal from the catchment to up is a response signal from the catchment from the input rainfall. In terms of the signal, we can draw like this: is the time with the discharge, okay? And we can divide into many parts. The first part is MA, is base flow realization from the before rainfall, and next D is a rainfall. After the rainfall, there is AB, is a rising rim, or after rainfall or during rainfall, and before when once the rainfall stop is a crest segment. CD is like the falling limbs, and the end is base flow realization. Okay. The many factor affects the runoff hydrographs. The first factor is we call the physiographic factor is from the basin characteristic, the shape, size, slope, and nature of the valley, elevation, and drainage density. The second part is the infiltration characteristic, land use, soil type, or the water storage. And the last part is channel characteristic. Okay. The other factor we call the climatic factor is from the storm characteristic, the intensity, duration, and initial loss and evapotranspiration. And this shows the example that if the shape of the basin is more circle, we expect compared to the long long shape, we expect that the hydrograph is for the circle is mean we get like the steep and high peak, but for this we got the flat and low peak, flat and fat and low peak. So it means it come from can explain by this because of the flow from this is coming from many points to the outlet with the same almost the same distance, so we expect that it come in the same time to the outlet. But in this case is the distance from many parts of the catchment is different, so we expect that they come to the outlet in different time, so we expect that flow the hydrograph is the low peak and fat shape, okay, a flat shape. And it show if you have like this like two catchment with the circle and the long shape, so we expect that is the two peak, one peak and the other peaks for combination of the hydrograph. This figure shows the effect of the catchment shape on hydrographs. If the shape is the large area is close to the outlet, okay, this one, and we expect that it's a short time and the peak is come closer, it comes soon. And if the main part of the catchment is upstream, this part is main part is upstream, so it's expect that the peak of the flow is come later. And if you have like this shape is have two is close to the outlet and upstream, so we expect that there is two peak of the flow come to the outlet. And this shows the effect of the drainage density. In this case, A is high density of the channel, so we expect that flow is come. The peak flow is come in really short time, but for the low density is longer time to the outlet. Okay. And this figure show different basin characteristics. For example, this for steeper slope, we expect that the hydrograph is high peak, okay, high peak, and And for the less roughness, we expect that the hydrograph is high peak as well. And for the short length and less storage, we expect a high peak. And for the greater length of channel, we expect a high peak. For the less infiltration, so we expect a high peak. And this short effect of urbanization before is mean infiltration rate is high. After is mean infiltration rate is very decreased. And it's connect to this curve. Before is mean once the infiltration rate is increased, we expect that the flow is like the peak is smaller and flatter and a flat shape. But once it's after urbanization, we expect that the peak increase, okay, and the peaks come faster compared to the before urbanization.